You have this system, 5x plus 5y equal 20, and then x minus 2y equals 13. So you want to solve the system. Now remember, when solving a system, what makes it a system is that you have two, and this is a system of linear equations. So what makes it a system, though, is you have two linear equations, and you want to find what makes the solution true to both of those at the same time. So what makes both equations true at the same time? What point? What x value, what y value? Notice, though, each equation has how many solutions? An infinite number. There's an infinite number of solutions. But when we solve it, we're finding the solutions that they have in common. And if you remember what we did yesterday, there were how many solutions that we had?
One.
Just one. We had one solution, 1 point. Okay, so when solving this by substitution, now this one is not a difficult one. When solving this by substitution, you look at both equations and you see which one you can get the variable by itself easily. So which one can you get the variable by itself easily?
Second one.
The second one, what letter? What variable?
X.
X. So the second equation, I'm going to rewrite this as x equal what? 2y plus 13, or 13 plus 2y. Okay. Now you circle this expression here, and then what do you do to that? Yeah, in place of x, in the other equation, you're going to substitute 2y plus 13. So I'm going to go here, and in place of that variable x, I'm going to substitute 2y plus 13. So then I get 5 times, in parentheses, 2y plus 13 plus 5y equals 20. So now I have a linear equation with just one variable. And that's something you had the first day of class. So how do you solve this linear equation? Distribute the 5. So I get 10y plus 5 times 13 is 65, is that correct?
Yeah.
Plus 5y equal 20. Then what? Combine like terms, I get 15y plus 65 equal 20. Next step. All right, so subtract 65 from both sides, combine like terms. I get 15y equals a negative 45. Okay, then what? Divide both sides by 15. So 15 divided by 15 is 1. 1 times y is y. So what's my y value? Negative 3. So my y value is negative 3. That's the only y value I ended up with. So how do you find your x value? You go back over here, and in place of y, you're going to substitute negative 3. So I get x equal 2 times y, which I'm saying is negative 3, plus 13. So that's negative 6 plus 13, which is 7. All right, now you're going to write as an ordered pair. So as an ordered pair, you're going to say what? 7 comma negative 3. All right, and you can check this. And when you check, you must always go back to the original problem, the original system. So when you check it, I need to make sure that both equations in my system are both true when I substitute this point. So I'm saying x is 7, y is negative 3. So I get 5 times x, which is 7, plus 5 times y, which is negative 3, and I want to see if that's equal to 20. What's 5 times 7? Is 35 plus a negative 15 equal to 20? Yes? Okay. Now I got to make sure that it's a solution here. So x is 7. I get 7 minus 2 times y. Y is negative 3, and I want to see if that's equal to 13. So that's 7. A negative 2 times a negative 3 is a positive 6. Is that equal to 13? Yes. All right. So this point makes both equations true at the same time. That's the only point that satisfies both the equation at the same time. So if you were to graph these, like we did yesterday, if you were to graph these two equations, what would you notice about their intersection?
It would be on 7, negative 3.
Right. So they would intersect in which quadrant? Where's 7, negative 3 located? Fourth quadrant. They would intersect in the fourth quadrant. All right. So the point of intersection when you graph is the solution. All right. So that was number 1. Oh, one other thing. On my math lab, when you put the solutions in my math lab, it's going to look like this. So my math lab, they're going to say something like the solution is, let's see, they have the solution set. So they use solution set is, and then they have blank, okay? And then they have type as an ordered pair. Type as an ordered pair. All right, now the way to have it, remember they're calling it a set. On day 3, we started talking about writing solutions as a set. When you say a set, what symbol do you use? The brace. Looks like this. All right, so that's how it's going to look in my math lab. Now here's how you have to write it. I'm going to write it in red. So if you do this, if you say 7, negative 3 like that, it's probably going to mark it wrong. Because you didn't write it as an ordered pair. An ordered pair, you must use what? Parentheses. So you got to make sure that when you type it in as an ordered pair, you put open parentheses, comma, 7, negative 3, and then close parentheses. So make sure you do that. Okay? All right, so again, this is what you have to do in my math lab. All right, now let's look at number 2. Okay, number 2, we have this. You have 8x plus 4y equal negative 20, and then 6x plus 6y equal negative 18. All right, again, the direction says solve by substitution. No other method, substitution. All right. So there's no variable that has coefficient 1, right? Okay. So you're going to have to do some division. But whatever variable you get, whatever variable you choose, see if you can get the variable by itself without having any fractions. You understand? So in other words, listen carefully. Suppose someone did this. Suppose someone took the first equation and said, well, I'm going to solve for x. There's going to be an issue there. Because if you solve for x, in the first one, watch. If you solve for x, you have to bring the 4y over. So it becomes 8x equals negative 4y minus 20, right? Then you have to divide both sides by what? By 8. So when you divide both sides by 8, notice what happens. You can get x equals negative 4y divided by 8, right? Minus 20 divided by 8. So you get fractions. You don't want to take this and substitute into the other equation, do you? All right, so taking that first equation, solving for x, is not a wise decision. So tell me what you think you might want to do instead.
Use the second one.
You could, but could someone still have stayed with the first equation? Solve for y. Someone could have stayed with the first equation and said, well, I thought I could solve for x. I did, but I ended up with fractions. I don't want to use this anymore. But what if I solve for y instead? I get 8x plus 4y equal negative 20. So let's solve for y. So I'm going to subtract 8x from both sides. And so I get 4y equals negative 8x minus 20. Y'all agree? Okay, what's the next step?
Divide both sides.
Divide both sides by 4, and notice what happens. I get y equals negative 8x divided by 4 is what?
Negative 2x.
Negative 2x. Negative 20 divided by 4 is
Negative 5.
negative 5. And so I end up with an expression without any fractions. So as you go through these, if it's not obvious that there's a coefficient of 1, and it won't always be like this example. So if you pick an equation and solve for a variable and you end up with fractions, try something else. All right. Now, you could have chosen the second equation as well, and it didn't matter, to be honest with you, whether you solve for x or y, because all of these are divisible by what? 6. Okay, it did not matter. All right, so if you had chosen the second equation, you could have solved for x, or you could have solved for y. But if you pick the first equation, solving for x is not going to be very friendly. So you need to solve for y instead. All right, so since I already dealt with the first equation, let's circle this expression. What do I do with this expression right here? Substitute into the second equation in place of what variable? Y. So I go here, and in place of y, I'm going to substitute negative 2x minus 5. So I get 6x plus 6 times y, and what's y? Negative 2x minus 5 equals negative 18. Okay, what's the next step? Distribute. So I get 6x minus 12x minus 30 equal negative 18. Next step. So that's what? Negative 6x minus 30 equal negative 18. Next step. All right. Combine like terms. I get negative 6x equals a, what's that, 12? And then finally do what? Divide both sides by negative 6, and you get x to be negative 2. Right, so you found the x coordinate of my solution. Now once you find the x coordinate, what's the next step? Go back here and substitute negative 2 in place of x. So I get y equals negative 2 times x. What's x? Minus 5. Negative 2 times negative 2 is a positive 4 minus 5, which is a negative 1. So your solution as an ordered pair is going to be what? Negative 2 comma negative 1. On my math lab, it's going to say the solution set is, and it's going to have this, a brace, and it's going to say type the answer as an ordered pair, just like we did a while ago. So what are you going to put in that blank?
Parentheses.
You must put parentheses,
Negative 2.
negative 2 comma negative 1.
Close parentheses.
Okay. All right, so that was number 2. Okay, let's look at number 3. All right, number 3, let's suppose we had this. Suppose we had this system. Suppose we had 2x plus y equal 7, and then minus 2x minus y equal 6. So 2x plus y equal 7, and then minus 2x minus y equals 6. Which equation might be the easiest to deal with? The first one.
First one,
And you would solve for what variable?
y.
Y. So in the first equation, I'm going to get y equals what? Be careful.
Y equals -2
Negative 2x
plus 7.
plus 7, or 7 minus 2x does not matter. Okay. Because remember, what you're doing here, if you didn't quite see this, you're subtracting 2x from both sides, right? And so when you combine like terms, you get y equals 7 minus 2x. Or you could say y equals negative 2x plus 7. So that's what you did. Okay, so once you solve for a variable, you're going to circle this expression on the other side, and that's what you're going to be substituting. So you're going to go to the other equation, and in place of variable y, you're going to substitute negative 2x plus 7. Now, you got to remember some things that you learned from that first week of school in terms of what we're about to do. So if you go back to what we just did, notice when I did the substitution right here, I said 6, and then in parentheses, I put that expression, right? Okay? In both cases, in all the cases, that's what I did. Now, when you get over here, you're going to say negative 2x minus, and then what are you going to put? Okay, you could say minus 1, but you're definitely going to need a what? Parentheses. Because you're going to substitute an expression in here, so you need parentheses, just like you did in the previous two examples. And so I'm going to get negative 2x plus 7 equals 6, correct? All right, then you're going to, when you go back to the previous ones that we did, then the next step was the distributive property. Same thing, distributive property. So what are you going to be distributing, though?
-1.
Negative 1. So I get negative 2x plus 2x minus 7 equal 6. Combine like terms, what do you get?
0 minus 7.
No. Oh, yeah, I agree. Yes, thank you. 0 minus 7, which is what, though?
1 x minus 7.
Oh, no, wait a minute.
Negative 2x plus x is 0, right?
0x.
0 and a negative 7 is a what? Negative 7.
So how can -6?
Equal 6. Okay? Now, on day 3, see how some of you already forgot some stuff you had? On day 3, where are those notes? Here we go. On day 3, do you remember when you solved a linear equation? This was on day 3. So we solved this linear equation. What did you notice?
Inconsistent.
The variable disappeared, right? Variable disappeared. And that's what we said that was a false statement. So in terms of the solution, what would you say? No solution. Well, the same thing applies here. Except this was a linear equation that we dealt with in that first week, and this is a system. So we said that this linear equation had no solution.
Basically, those lines don't cross anywhere.
So this system has no solution. Okay? That's what that means. So there is no solution. So in the blank, you would say no solution, or you would say what?
Inconsistent.
No. That empty set, thank you. The empty set. Okay? All right, now, if I were to graph these two, let me go ahead and graph them for you. Let me graph this. But you got to make a connection, guys, before I graph, you got to make a connection between what we did here and what we did on day 3. These are the notes from day 3. You have to make connections as we go along. So here we solved a linear equation that had no solution. That's what it looked like. And here we have a system. And that's what it looks like. That's a false statement. Negative 7 does not equal 6. So we end up with no solution. Now let me go ahead and graph this just real quickly, just to show you what it's going to look like. All right, so in both cases, to graph this, I'm going to get y by itself to graph. So to graph this, let's get y by itself. Remember yesterday I gave you that activity and some of you, most of you are fine, but some of you didn't know how to graph these lines? You just plus some points. Okay, so here, right here, I already got y by itself, so I'm going to graph this equation. Okay? Now let's graph this one as well. Now here I got to get y by itself, so let me go ahead and do some work here. Negative 2x minus y equals 6. Or you could do what? I really want to get y, right? Notice, now you could add 2x to both sides. I agree with that. You could. So he wanted to do that. That's fine. Let's do that. Combine like terms, I get negative y equals 2x plus 6. Y'all agree? But that's not y. So how to get y by itself? Negative 1. Wouldn't it have been easier, though, just to bring the y to the other side and then subtract 6? Okay. But since you want to do that, let's do that. So divide both sides by negative 1. Negative 1 divided by negative 1 is 1. So I get y equals, what's 2x divided by negative 1? Negative 2x. What's 6 divided by negative 1? Minus 6. All right, I'm going to graph this. And remember, graphing that we saw yesterday is not the most efficient way of doing these. But I want to graph this just to show you what the graphs look like. So I'm graphing this system. So I'm going to plot 2 points. So if x is 0, what's my y value here? 7. If x is, let's say, 2, what's my y value? Y equals negative 2 times 2 plus 7.
3.
Right. So I'm going to plot the point 0, 7, and 2, 3. So 0, 7 is right here, and then 2, 3 is right here. So I'm going to graph that line. I'm going to graph this line, and I end up with this line. Okay, so I get that line. Now the other one, I'm going to plot 2 points. Again, I'm going to use 0. If x is 0, I get negative 2 times 0 is 0, and what's 0 minus 6?
Negative 6.
Okay. If x is, let's say, 2 again, okay. If x is 2, no, it's not good. Well, I can, 2 is fine, because it'll fit in here. So if x is 2, I get y equals negative 2 times 2 minus 6, which is negative 4, and negative 6, which is what? Negative 10. All right, so I plot the point 0, negative 6, and 2, negative 10. So 0, negative 6, and 2, negative 10. Okay, and so I'm going to draw the line. And so you notice that the lines do not intersect, right? They don't intersect. So that's why you have no solution, because it did not intersect. So if you go back to our system, we had this false statement, so we say no solution. What that means is that if you were to graph it, these lines would not intersect. In fact, the lines are parallel. Lines are parallel. So remember yesterday we talked about parallel line. They don't intersect. Okay? All right. Now let's look at this one. Okay, so number 4. Let's make this number 4. Number 4, let's suppose we had negative 4x minus 2y equal negative 12, and then 2x plus y equals 6. Okay? All right, now, which equation would you choose right away?
Second one.
The second, because the coefficient of y is already 1. So if I take this equation right here and get y by itself, so subtract 2x on both sides, I get y equals
2x plus 6.
negative 2x plus 6, or 6 minus 2x, does not matter. So I take this expression, negative 2x plus 6, and I go to the other equation, and in place of the variable y, I substitute that expression, because that's what y equals. So I go here, and I substitute that expression. So I get negative 4x minus 2 times, in parentheses, that expression, negative 2x plus 6, equal negative 12. All right, what's the next step? Distribute.
Property
So I get negative 4x plus 4x minus 12 equals negative 12. Combine like terms, what do I end up with?
negative 12 equals negative 12.
So the variable disappeared. Variable disappeared. So what do you think the solution is?
Any real number?
Okay, so he says any real number. So if you go back to day 3, when we solved this linear equation, that was number 3 on day 3. We solved this linear equation, the variables disappeared, and we ended up with a true statement, right? And we said that the solution was any real number. You agree? Okay, so any real number you can think of would work. So any real number you pull out of the air would be a solution. Okay? And when we wrote the solution set, you recall, we said this. We had to write it as the set of x. On my math lab, you would say the set of x. Remember this symbol? The set of x, what did this symbol stand for? Such that x is a real number. Okay? So that's how you wrote the solution. Now, you could have said all real numbers, but on my math lab, this is what you would see.
I got a quick question for you.
Yes?
That method of writing that out, is that going to be on the testing one?
Possible. Not tomorrow, but possible. Okay? All right. Now, when we solve this linear equation, any real number worked, right? Any real number you can think of worked. Okay. So, when you look at this system of linear equations, this is a system. The variable disappeared, you ended up with a true statement, so there's going to be an infinite number of solutions. Y'all agree? He said all real numbers. I want to go ahead and graph this and kind of look at that statement that he mentioned. So let's go ahead and graph this. So this one, y is already by itself. So I'm going to graph that here on the same page as this one. So if I use a t-table, I get, if x is 0, I get negative 2 times 0 is 0. 0 plus 6 is 6. Okay. If x is, let's say, 2, I get y equals negative 2 times 2 plus 6, negative 4 plus 6, which is 2. Agree? So I'm going to plot the point 0, 6, and 2, 2. All right, and then we'll draw the line. Okay, so I get this line. Now remember, whenever you're graphing a line, what is that you're graphing?
Possible solution.
Not possible solutions, but the solutions. So that equation here, that equation has all these solutions. Okay? All right. So going back to the first one, one of the equations had this solution, the other equation had this solution, but the system had what? No solution. Because when solving a system, you're looking for the point that they have in common. So that's why there were no solutions here. All right, now to graph this one here, leave some space here. So to graph this one, all right, what you may want to do is get y by itself. Try and get y by itself to graph. Because if you look at everything that we've done so far in terms of graphing, we got y by itself. So let's get y by itself. So if I'm going to get y by itself, I'm going to go ahead and do this. Since the coefficient of y is negative, I'm going to bring the y term on the other side. So I'm going to add 2y to both sides. Okay? And so when I do that, I'm going to get 4x equals negative 12 plus 2y. Y'all agree? What's the next step? Add 12 to both sides. So I get 2y equals 4x plus 12. Y'all agree? What's the next?
Divide.
I'm sorry? Oh, I'm sorry. Thank you. All right, the original equation was negative 4x. All right, so then divide both sides by 2. Divide both sides by 2. I get y equals, look carefully, I get y equals negative 4x divided by 2 is a negative 2x. 12 divided by 2 is a positive 6. Now, watch carefully. Look at this right here, and then look at this one. What do you notice about them? They're the same. So what do you notice about the lines? They're going to be the same line. So basically, those two equations coincide. Using the word coincide. They overlap. Right? They overlap. So that's why we ended up with an infinite number of solutions, because if those two equations overlap, they're both on top of each other, then all these points are what? Solutions. Okay? And how many solutions are there? An infinite number. Okay, now listen carefully to my words. I'm going to go back to day 3. I'm going back to day 3. This was a linear equation, not a system. This was a linear equation. When I solved this linear equation, I ended up with how many solutions? Any other number. In fact, it was any real number would work, right? Any real number you pull out of the air would work. Okay? Because that was a linear equation. When I go to this system and I look at the graph, he said any number works. Is that true? Yes or no?
Yes.
So you're telling me that this point right here is a solution?
Any number along that line.
Okay, so you're going to kind of change your wording then, right? Because this is not a linear equation, it's a what? System. So not any point works. Not any point is a solution, because you remember we talked about this yesterday when we did that activity. These points are not solutions. Why? They don't lie in that line. The solutions are only the points that lie where? On that line. And how many are there? An infinite number. You can't just pull things out of the air and say it's a solution, right? Like you did on day 3. Day 3 you did. But that wasn't a system. That was just a linear equation. This is a system. Here you're dealing with a coordinate plane. So the correct wording would be this. Here's how you have to say it. You can't just say, like we did this, all real numbers. You cannot say that. Because it is not just any point. So you can't say that anymore. So here's how you're going to say it. All right. So I'm going to go back here. I'm going to say this. Remember in day 3, on my math lab, when there was when the solution is all real numbers, you did this, my math lab had it like this, remember this? All right, so you said the set of x such that x is a real number, right? Okay. Here, though, how many letters do we have? 2. And these are ordered pairs, so here's how you're going to write it. The set of x comma y, so it's an ordered pair, right? So it's not just a set of x, because how many letters are there? How many variables are there? 2. You're dealing with a coordinate plane. So a set of ordered pairs, x, y, such that, and then all you do is just rewrite one of those equations over, such that the ordered pair satisfies the equation, one of these equations, doesn't matter which one, such that negative 4x minus 2y equals negative 12. So that could be one of them. Or you could have said the set of ordered pairs x, y, such that, and then do the other one. It does not matter which one. Okay? But you cannot say all real numbers here, because you notice from our discussion that's not true. It's not just any real number. It's only those that lie where? On that line. And all you got to do is just write one of these equations. Doesn't matter which one, just one of them. So you understand how to write the equation, how to write a solution for a system that coincides? All right, so that's how you write it. Okay? All right. So that was a review of substitution. You had 2 new things, though. You had 2 new things where the system either had no solution or the system had an infinite number of solutions. Notice I didn't say all real numbers. I just said an infinite number of solutions. Okay? All right. Now,